let's look at what we call measurements. Still under scientific method. We saw that for us to prove whether the hypothesis is correct or wrong, we conduct an experiment, and when you conduct an experiment, you have to take measurements about the variables that you have. Remember, you have the independent variable and the dependent variables, and then you will have to control some variables, the controlled variables. These are variables that will change the relationship between the two variables, the independent and dependent. So you want to make sure that you control them, okay, exactly that they don't influence the relationship between the two variables. So, for example, if you're testing for the rate of reaction, whether the increase in temperature increases the rate of reaction, then the presence of the catalyst can influence the relationship between the rate of reaction and temperature. For you, you will see the reaction happening faster, and you may think it is because of temperature, yet it is about the presence of the catalyst. So you need to control the presence of the catalyst, for example, such that you basically investigate what you aim at investigating. So you have to record the temperature, you have to record the rate of reaction as a result of the relationship between how much products are you having in relation to time. So in relation to time, and then you determine the rate of reaction. But basically, not to complicate and confuse you, we are saying that we take measurements. You measure things and then you tabulate them. So what do you measure, and what are the things that you need to take into consideration when you record these measurements? Okay, we measure mass, we measure volume, we measure length. What is important in these aspects? What are they? What should we know about them? Okay, how should we make sure that we take the appropriate measurements of each of the things that I've just mentioned? That's why we are having this presentation. Okay, so on the slide, you already see that we have a balance, okay, where we have placed, we use this object here that we are determining the mass, and this is the weighing machine. So this is just going to depict to you that we are about measuring things. So what are these measurements? When we measure something, we get numerical information. We get a number. We get a numerical figure. Okay, whether it is 1, whether it is 2, whether it is 3, whether it is 10, it is measurements are concerned with measuring quantitative, or it gives us what we call quantitative data. Okay, and from this moment, I want you to get the difference between information and the data. Okay, so we still go back to our example of you have the temperature and then the products. Okay, the mass of the products of the reaction. So at temperature this, temperature let us say 25, 26, 27. This is hypothetical, so shouldn't bother you a lot. Okay, and then how much of the product are you getting? So assuming we are having 40, 50, and then maybe 62 there. So this the figures that you have entered, that you have collected about your experiment, is what we call data. It does not tell us anything more. Okay, so if you collect data, I mean information about a particular parameter that you're investigating, what you get is what you call data. Now, if you explain this information, you say that as temperature increases, the rate of reaction also increases, then that becomes information. If you add explanation to these figures, it becomes information. So we get information from data. Okay? Data comes from information. It's something that I want you to know. So we are saying that when we collect measurements, these measurements are quantitative. They are numbers, so they are numerical. And for example, in our daily lives, we actually rely on these numbers a lot to make decisions. Okay? For example, if you're going to make a cake at home, you need to know how much sugar you have to put, how much baking powder are you going to put in there. Okay? And a lot of other ingredients. Okay, that means the numbers are important. They help us in knowing what to do. Okay, the numbers are very important in our daily lives and also in scientific endeavors, just like what I've just explained here. Okay, so that's why we actually take these measurements. The numbers do not make sense if they do not have units. So, for example, this is 2. This 2, if it was alone, it would make no sense. But if we add the kilogram to it, it makes sense. So putting a figure alone, that numerical figure alone is not enough. It has to have a unit. So what we are saying is that when we talk about quantities, we're talking about how much. But that how much has to have an attachment that defines what that how much is. So you can say, like, if I tell you, I'm going to give you 3, I'm going to give you 3. So you ask me 3 what? 3 pens, 3 computers. Okay, so I need to put a unit to it. The 3 has to have a unit. So in science, we're interested in the figure, but also in the unit. Okay, so the units now is what we call. It is what allows us to make standardization or to standardize comparisons. Okay, remember in science we are interested in what we call the ability to reproduce our experiments and also get the same results. That's what we are interested in science. So therefore, if you're going to say 2 without specifying 2 what? 2 milligrams, 2 liters. If you don't specify, then you're not going to be, another person cannot do exactly what you did. And that is where the word standardized comparisons come in, such that all of us are on the same standard. When we say 2 kilogram, the 2 kilogram in your village is the 2 kilogram in my village. It will never change. So that means that is the standard. Okay? So that's why we have these units. These units allow us to have standards and then also consistency and clarity. Okay, so when we are communicating, we need to be very clear. I'm going to give you 2 pens. I'm going to give you 2 liters of milk. I'm going to give you 3 liters of milk. Okay, that means that is going to be consistent throughout. If I say that all the school going children are going to be given a cup of milk at school, that means that everyone will get the same amount, because the cup has to be of the same size, and then everyone is going to get the same amount of milk. So no one is going to be cheated. And this is why units are very important. Okay? So, let us now come to what we call international system of units. These ones still, remember the example of the cup? If you say that everyone is going to receive a cup of milk at school, the cup of milk that you're using is not the same cup of milk that I am using, because others are big, others are small. So that means that it's not going to be consistent. Because your cup is bigger than mine, you're going to get more milk than me. That is not something that maybe you want. You want to share things equally, isn't it? So therefore, the international system of units comes in to solve that problem. Scientists need to be communicating with using the same language. If it is a cup of milk, the sizes are different, then you're not going to be consistent. Therefore, instead of saying a cup of milk, why don't you say that everyone is going to receive 500 ml of milk? So if you use this one, 500 ml of milk, everyone is going to receive the same, and regardless of whether they take a cup or they take in a container or in a bottle, regardless, the amount will be the same. So that is where the international unit of international system of units can be. Scientists around the world globally establish this system of how we can quantify certain things and be able to, if we say it is 2 kilograms, the 2 kilograms is the same ground. The way we measure things. So what are the things that we can measure and what units to use? Okay? That is what the international system of units is concerned. There is this other word, the system is international units. It is a French thing, a French word or French phrase that basically represents the international system. That's what it is. It's nothing much. It's about making sure that the units are consistent and we can communicate with consistency and clarity around the world. If you tell a scientist 22 degrees centigrade, everyone will know what 22 degrees centigrade is. If you tell them 2 kilograms, they know what it means. They say it's very, very, very clear. Okay. Now, these SI units, they have in the short forms for SI, for the international system of units is what we call SI units. So the SI units comprises of 7 base units, that every quantity that we measure is based on the 7 units, and it is from these 7 units that we derive other units of measurements that we carry out. So the 7 units are here. Length, it's about distance. Mass, we also look at that. Time, electric current. Thermodynamic temperature, the amount of a substance, luminous intensity. These are the 7 quantities, and these are their units. Meter is for length, kilogram is for mass, second is for time, ampere is for electric current, and then mole is for amount of substance, and then candela is for luminous intensity. We always in science, we may not always write 22 kilometers or 22 meters. We may just say 22 m. This is a small m. It is very important for you to know it. It's a small m. If you always put this, then someone will know that this m is the meters. A scientist will always know that. Kilogram, we always know that it is the kg. The small s means seconds. The ampere is presented by a capital A. So it is very important for you to know when to use the small letter and when to use the capital letter. Kelvin, it is about the thermodynamic temperature. Capital K. Mole, all small letters, it is for mole. And then CD, which is for candela, is luminous intensity. So CD here. Those are the 7 fundamental or base units of SI. Okay, the 7 fundamental units and these ones. Okay, so we also have others that we get from this area, we shall look at just shortly. So there is something that you really need to know, and it will make work easier for you in interpreting information. Okay, and even in calculations. For example, you buy data to access the internet or to watch this video, for example. This data that you buy, your internet service provider quantifies the data that you buy. So you buy what we call MBs, you actually call them MBs, megabytes. You also can buy gigabytes. You can buy terabyte. Okay, so I want you to notice the giga here, terabyte here, and then the megabytes here for the data that we use. Because I just want to use an example that you know. These are the tera, the giga, the mega. These are prefixes. Okay, these are prefixes. So therefore, these prefixes would they really mean? And even for the other prefixes that we have here, we have kilo, hecto, deca, deci, centi, milli. Okay, these things, these prefixes carry a figure. They carry a figure that you should always have in your mind. Okay, if someone talks about kilo, it could be kilowatt, it could be kilogram, it could be kilometers, whatever it is, as long as it has kilo, you just know it is about 1,000, which is simply written as 10 to the power 3 is the same as this, what we have here. Kilo, just know that. And then which other example can we use that we always use very much? So from this point going upwards, you can notice that the power is in positives, and then from this point going downwards, the power is in negatives. You can see -1, -3, negative. Okay, these figures are always provide it to you maybe in some table if you want to do some calculation. But it's also very important for you to know that Baker is basically 10. Baker is basically 10. 10 is, okay, so if you have that, this is equal to 10. Okay, it's basically that. Hectare, just know it is 10 to power 2. And then kilo, I've just explained. Mega, just know it is 10 power 6. Okay, giga, just know it is 10 power 9. Okay, just know they have implications, especially in conversions. Okay, so if you know, they actually derived from these meters. All these are actually for distance or length. Okay, but they can be replaced with the milliliters, centiliters, deciliters, a liter, decaliter, hectoliter, kiloliter, megaliter. You get it. Okay, this can be replaced by other parameters. Okay, whether it is volume, whether it is mass, whether it is distance. Okay, even the example of the bytes that we talked about. Okay, I hope that is very clear to you. So the derived units, these are not the fundamental units that we saw. We said that we have 7 fundamental units, but here we are saying that these are units that you get from the fundamental units. So that's why we call them derived. Derived means to get something from something else. That's the meaning of the word derived. So derived units means that we get them from other units. Okay, so the combination of the 7 base units in different ways gives us what we call the derived units. So we have area. Area is basically length times width. You know this, right? Then they have the volume, which is length times height times width. Volume. If it is a tube, it is length tube, right? L tube. Density, it is mass divided by volume. Okay. Acceleration is distance covered by unit time. Not by unit time, per second squared. This is what we call acceleration. And then force, pressure, work, power, frequency, and energy. Some of these quantities, what you basically study in your physics classes. Okay, so we may not really go into them in this presentation, but just know that the 7 are the fundamental units, but from the 7 we can get others that we call the derived units. Okay, and they get their units from how they relate, how the different units relate to one another. So let's look at some of the common measurements that you have in your chemistry classes, okay, and practicals. Quantity, you always be measuring quantity, and in the laboratory you can use the balance, the 3-point balance, or you can use the digital weighing machine. Okay, mass is basically quantity or the amount of matter a given substance or a given object has. Okay, so when we want to know how to produce a particular product, we may need to know how much we need to add. Okay, so A plus B to give us C, we need to know how much to add, how much should A be and how much B should be. eventually we shall know how much C will be. Okay, so we carry out these measurements. The units are kilograms. Okay, so for all the weighing scales, whether it is a triple balance, 2-point balance, or it is this digital weighing scale, they are all calibrated. That means they are being made to have the units as kilograms, because they are basically measuring mass. This is very important for accuracy. So this digital one may be more accurate than this one, which you have to move to make sure that it balances. Often weight is confused with mass. Okay, we get weight by multiplying mass times the acceleration due to gravity. So we often say weight is equal to mg. It's the mass times the acceleration due to gravity, which we often take as 10. Okay. So weight is not the same as mass. Okay. So what is weight? Weight is basically the force exerted on any object or on an object due to the force of gravity. Okay, so weight has direction, mass does not have. So that means that weight is a vector quantity, whereas mass is a scalar quantity. You know this, especially in physics. Okay, so the unit is what you call Newton. Newton is the SI unit of weight, and Newton is defined as the force required to accelerate 1 kilogram mass at 1 meter per second squared. So this is 10 meters per second squared. This 10 here. Okay. So we have weighing scales that basically give us the weight in kilogram for everyday use, but basically to determine your weight, it is the kilograms times 10. So we come to weight, to length. We come to length, which is about distance. Okay, the longest dimension of an object. So we use meters as the SI units for length. Okay, for you to understand a meter, what a meter represents, just know that most of the doors are about 1 meter. 1 meter. The door that you're using is about 1 meter. Okay, and then of course, if you're going to describe to someone where you are, you can say you can turn left and then move a distance of 100 meters. If the distance is long, you cannot, maybe it is not proper for you to say and move a distance of 3,000 meters. It will be confusing. Maybe you can say and move a distance of 3 kilometers. So that means that you need to know which units to use. If it is a long distance, then kilometers may be very okay to use. If it is a shorter distance, meters, or if it says it's about this, then centimeters may be appropriate. Okay? And let's look at these are simple calculations that you can make about area and volume, so I won't go into them because I've just explained them. But of course, in physics, you have a deeper look at these things, how to calculate volume for different shapes, how to calculate area for different shapes. This is also there in mathematics. So if you want to know how to calculate these things, you can basically go to mathematics and check the resources there. So volume is also something that we deal with a lot in chemistry. It's the amount of space occupied by an object. The SI units are meters cubed. But for usually, convenience is very important. When you're handling things in the laboratory, usually you don't use bigger, larger volumes, you use smaller volumes for units and things like that. So you can have cubic centimeters. Okay, that's some of the volume that you or units that you can use when you're dealing with volume. Yes, for example, liters, milliliters, these are also volume-related units that you can use. Density, we have already said that density is about mass, the ratio of mass to volume. Okay, it represents how packed matter is. It is the units are, you combine the unit of mass and then the unit for volume, which is cubic meter. So the units for density are kilometer per, kilogram per unit per cubic centimeter per cubic meter. Okay, that will be edited out. The units for density are kilogram per cubic meters. Okay, but you can also use other units for convenience, just like what I've just said. So conversions, like what I've just explained earlier on, that table, this table that we looked at, this table allows you to make conversions very easily. So you basically say, for example, for you to get, for you to convert meters into kilometers, you say that 1 kilometer is equal to 1,000 meters. So if you're looking for how many kilometers are in 500, then you basically do cross multiplication. So it will be it will be 500 divided by 1,000. You'll be able to get the kilometers that are in 500 meters. Okay, so the conversion factor is basically this. This is what we call the conversion factor. So you can always get that from that table. And there are also different tables that you can always use. And some of the things already done, you have already done them, for example, in your primary level education. Make the conversions. Okay? So that basically marks the end of this presentation, where we have looked at the measurements that we carry out and the units that we use for making sure that we are consistent in our communication, that people can reproduce the same results that we have in our experiments if we use what is internationally accepted. So we have talked about the SI units and the derived quantities. Thank you for listening.